Hey everyone, welcome back to the channel. Today, we're diving into a cosmic mystery that's been buzzing in the astronomy world. We're talking about an object known as 3I Atlas, or more formally, 3I Borisov. You might remember it as the second interstellar visitor ever detected in our solar system, after the famous Oumuamua. But unlike Oumuamua, 3I Borisov is a comet, and it's been putting on quite a show. So, what's the big deal? Well, recent observations have shown something peculiar. As 3I Atlas gets closer to the sun, it appears to be slowing down. Now, you might think, slowing down? Isn't gravity supposed to speed things up as they approach a massive object like the sun? And you'd be absolutely right. This is where things get interesting. Normally, a comet follows a predictable path, a hyperbolic trajectory in this case, accelerating as it slingshots around our star. But 3I Atlas isn't playing by the standard rules. This unexpected deceleration has sparked a lot of conversation. And whenever something in space behaves unexpectedly, one question inevitably pops up. Could this be a sign of something not natural? Could it be aliens? The idea of an interstellar object adjusting its speed is classic science fiction. Imagine a massive alien probe using some kind of retro thruster to slow down. Maybe to get a better look at our solar system, or perhaps even to enter a stable orbit. It's a thrilling thought, right? It immediately brings back memories of Oumuamua and the debates about whether it was an alien solar sail. Let's explore this alien probe theory for a moment. If 3I Atlas were an artificial object, slowing down would make sense. An intelligent civilization wanting to study our solar system would need to break against the sun's immense gravity. A simple flyby at incredible speeds gives you limited data. But if you can slow down, you can observe more, maybe even deploy smaller probes. The deceleration we're seeing could, in this sci-fi scenario, be the main engine burn of an alien craft positioning itself for a long-term mission. It has an idea that captures the imagination because it taps into that fundamental human question. Are we alone? However, before we jump to conclusions and prepare a welcome party, science demands that we exhaust all natural explanations first. And in the case of comets, there's a very powerful and well-known phenomenon that can cause this kind of behavior: outgassing. Comets are often called dirty snowballs for a reason. They are chunks of ice, rock, and dust left over from the formation of star systems. As a comet like 3I Atlas approaches the sun, the increasing heat causes its ices to vaporize, shooting jets of gas and dust out into space. Think of it like a tiny, natural rocket engine. These jets of material erupting from the comet's surface create a thrust. If these jets are pointing in the direction of the comet's travel, act like a brake, pushing against its forward momentum and causing it to slow down. This is what astronomers call a non-gravitational force. It's not a new or mysterious concept. We've observed this with many comets from our own solar system. The comet's rotation, the location of the active jets on its surface, and the composition of its ice all play a role in how it accelerates or decelerates. So, how can we tell if it's natural outgassing or alien engines? Scientists are looking at the data very closely. One of the biggest clues is the coma, that fuzzy, glowing halo of gas and dust that surrounds the comet's nucleus. We can see this coma around 3I Atlas, and we can even analyze the chemical composition of the gas being released. So far, the gases detected, like cyanide and diatomic carbon, are exactly what we'd expect to see from a normal, run-of-the-mill comet. There's no sign of exotic fuel or anything that would suggest artificial propulsion. The behavior of the outgassing also provides clues. If it were an engine, you might expect a very controlled, continuous burn. Natural outgassing, on the other hand, is often chaotic and uneven. A comet's surface isn't uniform. It has active regions and dormant regions. As it tumbles through space, different parts get heated by the sun, causing bursts of activity. This can lead to the jerky, unpredictable changes in speed that we're seeing with 3i Atlas. The observed deceleration fits perfectly within the models of cometary outgassing. In fact, this isn't even the first time we've seen this. Comet Oumuamua also showed a slight non-gravitational acceleration as it left our solar system. While some, like Harvard astronomer Avi Loeb, famously suggested it could be an alien solar sail pushed by sunlight, the scientific consensus leaned towards outgassing from a body unlike any we'd seen before. The main difference was that we couldn't see a visible coma around Oumuamua, which made the outgassing theory harder to prove. With 3i Atlas, the situation is much clearer because we can directly observe the coma and the jets of material. So, to answer the big question, is 3i Atlas slowing down a sign of alien activity? The evidence overwhelmingly points to no. It's almost certainly a beautiful, natural display of cometary physics. The outgassing from its surface is acting as a natural brake, pushing against its trajectory and causing the slight deceleration. While the idea of an alien spacecraft is incredibly exciting, the reality is often just as fascinating. We are witnessing up close a visitor from another star system behaving exactly as our scientific models predict it should. And that in itself is amazing. Studying 3i Atlas gives us an unprecedented opportunity to analyze a piece of another solar system. The materials that make up this comet were formed around a different star, billions of miles away. By understanding its composition, we can learn more about how other star systems form and evolve, and whether the building blocks of life, which we know exist in our own comets, are common throughout the galaxy. This story is a perfect example of the scientific process in action. We see something unusual, an object slowing down when it should be speeding up. We propose different hypotheses, from the mundane to the extraordinary. Then we gather more data and test those hypotheses. In this case, the natural explanation of outgassing is the one that best fits all the available evidence. It might not be the alien encounter some were hoping for, but it's a profound scientific discovery nonetheless. We're learning that comets, even those from distant stars, are governed by the same physical laws we see here at home. This reinforces our understanding of the universe and our place in it. The cosmos is a vast and wondrous place, and sometimes the most amazing truths are hidden in the elegant simplicity of nature. Thank you so much for joining me on this cosmic journey today. What do you think? Were you hoping for aliens, or are you just as fascinated by the science of comets? Let me know down in the comments. If you enjoyed this video, please give it a thumbs up and consider subscribing for more explorations of the mysteries of our universe. We'll see you in the next one.